Okay, so let's take a look at this next sequence here. So let's look at the common ratio, or actually let's just look to see if we have a common ratio. So 3 divided by 1 in this case. Well, 3 divided by 1 will give a value of, and I'm going to write that below here, that will give a value of 3. And then let's see, our next ratio here is 9 over 3. So far it looks like we're going to have a common ratio because, well, so far I have 3 and 3, but you can't just stop after the first two terms in the sequence. You should follow through the entire sequence. So now I'm going to take 12 and divide by 9, so 12 over 9. And when I actually simplify this fraction, I'm going to get 4 thirds, and I can tell now that although it started out looking like it could be a common ratio here, well, it's not constant throughout. Therefore, there is no common ratio. This is not, or it could not be, a geometric sequence. Let's move forward from here. Alright, so in this next sequence, let's go ahead and look at the ratio here. So I have 27 over 81, and then after that I have 9 over 27, and then 3 over 9, and then finally 1 over 3, or 1/3 here. Alright, so let's see what we get here. I'm just going to change colors again. So can I simplify this fraction? I actually can't simplify this fraction any further, so I'm just going to leave it as 1/3, but I know I can simplify 3/9 into 1/3, and I can also simplify 9/27. If I divide the numerator and denominator by 9, it will simplify into 1/3. And then finally, this last one, let's take a look here. If I divide 27 by 27, I'll get 1. And if I divide 81 by 27, I'll get 3. So it looks like my ratio is constant throughout, and my common ratio for this sequence here is 1/3. So it looks like, yes, I could have a geometric sequence. And in fact, one thing I want to do, I just want to fix this a little bit. I'm just going to put another comma there and just 3 dots to say that this sequence continues on forever, infinitely.